This one says, is this bounded from above, below, or bounded on its domain, or unbounded on its domain? Well, let's look at the graph. So the first thing we do is we're going to graph it. We're going to say the square root, whoops, wrong one. The square root of 9 minus x squared, whoops, squared. And we'll graph it. Okay. Well, it's certainly bounded from above. Do you guys agree? It has a y. It has a maximum y value. It kind of looks like it might be bounded from below, but I really suspect that that binding is due to the domain, right? Now, why do I say that that is due to the domain, the boundedness?
You don't have enough domain to really.
Yeah, so it's a square root, so we have a restricted domain. So the domain of this thing can be, let's think about that. When we see the square root, what's the issue with square roots? Yeah, I can't take the square root of a negative number, right? So this stuff right here has to be, in other words, 9 minus x squared has to be greater than 0. Okay? And so there's lots of ways we can solve this. If I say x squared, and I move the 9 over, I get a negative 9. If I multiply by negative, I got to flip the sign. And then I get x has to be less than or equal to, and you got to be careful. This is where it's tricky. If I were to ignore the inequality symbol and just solve for 0, let's do it this way, and then we'll come back and think about it. It can't equal 0, right? So then if I get negative x can't equal negative 9, right? And then I could say x squared cannot equal 9, take the square root of both sides. And so then I get x cannot equal negative 3 or positive 3. And then I gotta think about that, because the inequality is the challenge. So we have an issue at 3 or negative 3. And in reality, if you think of the number line, I got negative 3 here. This isn't probably the most conventional way, but sometimes if I do it this way, you guys understand it a little better. If I let x be greater than 3, in other words, I pick 4, and I plug it in here, what happens? I would say 9 minus 4 squared is equal to the square root of 9 minus 16 squared. Uh-oh. So what does that tell you?
That it's not.
That it can't be greater than 3. So what's another way to say x cannot be greater than 3?
X is less than 2.
Yeah, so we say that x is less than or equal to 3. It can be, all right? Now, I think a similar thing happens if I go this way to this side of negative 3. So let's try it. If I say 9 minus negative 4 squared. Well, hey, that's the same thing, isn't it? 9 minus 16. Clearly, this is a negative number, right? So x can't be less than, what's another way to say that? X has to be greater than or equal to negative 3. And truthfully, I could combine these and say x is trapped between negative 3 and 3. Does that make sense? Because really, x can live here, right? Is it bounded from above or below?
Okay, it's just bounded.
Well, let's see. You tell me what to push.
Bounded.
Is it unbounded?
No.
No, it's not unbounded. It's bounded from above, but it's also bounded from below.
It's just bounded.
So it's just bounded, right?